let's take a look at this earthquake analysis problem here. So it says earthquakes produce several types of shock waves. The most well-known are the P wave, P for primary, meaning it's the first one to get there, or P for pressure, meaning it's a longitudinal wave, meaning it vibrates the ground back and forth as it moves. The S wave, or the secondary wave, or shear wave, secondary meaning it gets there second, shear meaning it moves up and down, it's a transverse wave, meaning that it moves the ground up and down as it moves. These two waves in the Earth's crust, the P wave travels at about 6.5 kilometers per second. Now we can keep it in kilometers per second as long as we remember that our positions are going to come out in kilometers. If you feel more comfortable changing this to 6,500 meters per second, by all means do so. While the S wave moves at about 3.5 kilometers per second, the actual speeds vary depending on the type of material they are going through. The time delay between the arrival of these two waves at a seismic recording station tells the geologist how far away the earthquake has occurred. And if the time delay is 33 seconds, how far from the seismic station did the earthquake occur? Okay, so remember, these two waves, the earthquake happened and they start at the same time. Now one moves a little faster than the other, and you'll notice that they get a distance apart. And so if this is my seismic station here, the primary wave hits it, and then the secondary wave hits it. And that time delay tells me how far away it is. The bigger the time delay, the further those waves have traveled and the further they've separated because one's going faster than the other. So this is going to be a simultaneous motion problem. And we're going to assume one-dimensional motion. There is some reflection that happens with inside the Earth, but we're just going to assume one-dimensional motion here. So the primary wave, we can say x naught x, v naught v, a, and t because it's a 1D motion problem. And same for the S wave, x naught x, v naught v, a, and t. All right, so whenever we have simultaneous motion problems, there's going to be some common things. So the first thing we have to have in common is we have to have them on the same coordinate system, meaning that our primary wave and our S wave both originate at the same location, the earthquake epicenter. So they initially are at both x equals 0. Both of them end at the seismic recording station, some distance x away. These values are going to be the same. Think about two runners running a race. If one runner runs faster than the other, the more time you give that faster runner to move, the further ahead they're going to get, but they're still running the same race. It's not like we look at some later point in time and see how far did they go. They're just running a specific race. So that'll be the same. Now, we are going to assume that these are traveling through relatively consistent materials and those speeds stay the same. That's a pretty big assumption, but we're going to go with it. So the primary wave is not speeding up or slowing down. It's not accelerating. So that tells me that the speed is not changing. So the start and the end velocities will be the same. And so this is our 6.5 kilometers per second. Same thing happening over here for the S wave. Moving at 3.5 kilometers per second. Okay, now the times are different by 33 seconds. So what we tend to do here is we tend to say, okay, which one's the shorter time? Which one got there in the shortest amount of time? Well, that's going to be the primary wave, made it in the shortest amount of time. The S wave took a little bit longer. It took 33 seconds longer. So the time for the S wave is going to be the same as the time for the P wave plus that 33 seconds. Now I could say, well, the time for the S wave was T. That would make the time for the P wave T minus 33 seconds because it took 33 seconds less. So you can flip them around. I tend to always do the plus version instead of the minus version. So the shorter time gets T, the longer time gets the shorter time plus the extra time. All right, now that we have this set up, we have two unknowns. And so the problem we run into here is whenever your acceleration is 0, you're always using equation number 2. So I get x equals x naught plus v naught t plus 1/2 at squared. So the acceleration goes to 0, this was 0, but the problem is I have x is equal to 6.5 t. I have two unknowns. And the same thing is going to happen over here. I'm going to have my same equation 2. I'm just going to be left with x is equal to 3.5 times t plus 33. I have two equations, two unknowns, so that means I need a system of equations. So the easiest way to solve this system is just to set them equal to each other, solve for t, and then plug that time back in here and solve for x. I could also plug that time back in here and solve for this x since they are the same. So let's go ahead and do that. So I have 6.5t is equal to 3.5t plus whatever 33 times 3.5 is. Subtract that over, so I get 3t is equal to 33 times 3.5. Divide my 3 over, and so I get a time of whatever 11 times 3.5 is. And so my time comes out to be, what was it, 38 something? 38.5 seconds. So now that I know my time, I can plug that back in here, and I can figure out that distance. So 6.5 times 38.5 seconds gives me a total distance of 250 kilometers. Now, it's kilometers because this is kilometers per second. Kilometers per second times seconds gives me kilometers. So 250 kilometers away. If you don't remember from 8th grade, so each of these recording stations will go ahead and figure out how far away it is, and then they use triangulation. So they basically take a map, and a 3D map, and they draw a sphere that has a radius of 250 kilometers for this one. They draw another sphere, and they look where those spheres overlap. And when they have a third one, now they look at where all 3 spheres overlap, and that is the epicenter of that earthquake. You tend to use more than 3 just because you're not always positive that this number is staying the same. There you go.